Hey guys, today we are going to start our radical unit. So we just took our test over matrices and we're going to move forward. We're going to start our radical unit. So make sure you have printed your notes from what we are doing today. If you have not, then go ahead and pause this video and get those notes out and ready. All right, we're going to review properties of exponents and we're going to review simplifying radicals today first. Okay, so if I ask you to simplify 2 to the power of 5, that means you take 2, multiply it to itself 5 times, right? 2 times 2 times 2 times 2 times 2. What does that give you? It gives me 32, okay? 2 squared plus 2 cubed, there we go, is the same thing, okay? Because 2 times 2 is 4. 2 times 2 times 2 is 8. 4 times 8 gives us 32, okay? So notice how we got the same answer through here. What property is that showing us? Do you remember? So it looks like my exponent of 5 got split up to be the exponent of 2 and 3. As long as we're multiplying and our bases are the same, it's the same thing as adding our exponents together. So those are the same thing. Okay. Here we have 2 times 3 in parentheses, and then it's being squared. So 2 times 3 is 6, and then 6 squared is 36. Over here, looks like we've split it up. Let's see if it does the same thing, okay? 2 squared is 4. 3 squared is 9. 4 times 3, 36. So, looks like if we're in parentheses, both pieces in my parentheses got the exponent on the outside. So, if I distribute the exponent to a product, 2 pieces being multiplied, we get the same result. All right? And then here we have 2 to the power of 6, and then we have 2 squared, and then it's being cubed. So 2 to the power of 6 is equal to 64. 2 squared is 4. 4 cubed is 64. Okay, so those also end up being the same thing. So if I have a power to a power, I can multiply those to simplify it, and that's the same thing as saying 2 to the power of 6. Okay? Let's see if we can do it again with some variables involved. Okay? So we have 3x times 4 to the power 4x to the power of 5, okay? Well, the easy thing here is 3 times 4, right? 3 times 4, we know that's going to give me 12. My x's, though, I need to add my exponents because I'm multiplying, okay? There is an exponent here. Technically, it's an exponent of 1. So x1 and x5 gives me x to the power of 6. So that becomes 12x to the power of 6. All right, number 8. Okay, I have parentheses involved, and then it's all being raised to the same power so that I can distribute that exponent. So that's the same thing as saying 2 to the power of 3 times a 2 to the power of 3. So that's also the same thing as saying 6, because power to a power we get to multiply. So this is going to simplify to be 8a to the power of 6. Number 9, same thing. I have a product, so I'm going to distribute my exponent. So that's going to be a to the power of 2, and then b to the power of 4 to the power of 2 I get to multiply. So that's going to give me b to the power of 8. Now I have mn being raised to the power of 2, so power to a power, we get to multiply. N times 2 is just the same thing as saying 2n. So that becomes m to the power of 2n. Okay. Let's do some more exponent rules. Going to get a little bit more involved here. Number 11, we're still doing our product rule, which means we get to add exponents as long as their bases are the same. Okay. So here we have our coefficients 2 and -5. Okay, that's going to give me -10, right? Then we have x2 and x4. So I'm going to be able to add those together. And then I have y3 and y2. I'm going to be able to add those together. So it's going to become -10 x to the power of 6 and y to the power of 5. All right, so with product rule, I'm able to add my exponents together. What do you think is going to happen if I have a quotient or a division going on? Right, we're going to subtract. So x to the power of 10 over x to the power of 7, Well, that is the same thing as taking my numerator minus my denominator, and we get x to the power of 3. Okay. Number 14, okay, we got negatives going on. Oh, what am I doing? I skipped 13. Let's go back down here. 13, okay, negative x to the power of 3 also being raised to the power of 5. Now that negative x, that doesn't mean anything. Don't get thrown off. I still have a power raised to a power. So I'm going to multiply those together. I get negative x is still there. That's still the base. But now my exponent is 15. All right. Number 14. Here we go. I have a negative 5. I just saw it doesn't change anything. I have negative exponents, which could change something, but let's do the rule that I know first. Okay. Power to a power. Negative 1 times negative 2, well, isn't that just 2, right? So now I have negative 5 as my base, and my new exponent is 2. And what is negative 5 squared? Oops, sorry. It is 25 as our result for that one. Over here. So that became negative 5 to the power of 2, which becomes positive 25. Okay. So my negative and my exponent got canceled out in number 14. Number 15, it's not. Okay. If I have a quotient, which is division, inside of parentheses, and I have an exponent on the outside, each piece of my quotient is going to get that exponent. Okay. So that's the same thing as saying negative 2 to the negative 2 power and 3 to the negative 2 power. Okay. When we have negative exponents, you might remember in Algebra 1, that means that that piece of your fraction is in the wrong spot. So negative 2 squared should not be on the top. It should be on the bottom because my exponent's negative. Okay? And then 3 to the negative 2 power in the bottom is wrong. It should be at the top. So I can rewrite this as putting 3 squared in my numerator and negative 2 squared in my denominator. Now that I've put them in their right places, now we can simplify. 3 squared is 9. Negative 2 squared is 4. Okay? So look at number 16. I have some negative exponents. I can't do any subtracting because x and y are not the same base. They're different variables. But I notice that x has a power of negative 1 and y has a power of negative 2. So the x and the y are in the wrong places. The 3 is fine. Technically, my exponent for 3 is a positive 1. So I'm not moving my 3. But my y squared needs to be in the numerator, and my x to the power of 1 needs to be in my denominator. All right? So that's kind of your review of property of exponents. So don't forget them. You're going to need them. All right? Now let's go into taking roots, certain roots. Okay? If we have a to the power of n that's equal to b, with a and b both being real numbers, and n is a positive integer, right, so it's a positive number, then a is an nth root of b. Okay? If n is odd, there is one real nth root of b denoted in radical form as n root b. The only nth root of 0, by the way, is 0. If n is even and b is positive, there are two nth roots of b. The positive root is the principal root, and its symbol is n root of b. The negative root is opposite, or negative n root b. And b is negative. There are no real nth root. That is very fancy. So let's generalize this. What we're saying is you can take an odd root of a negative number, okay, and you'll still get a negative number as your result. But with an even number, okay, you can only take an even root of a positive number, okay? So you can do an odd root of a negative number, and that's fine. But with even roots, you can only do positive numbers, okay? Let's think about it. If I take negative 5 and I multiply it to itself twice, we get positive 25, right? There's no way for me, a square root means two of the exact same thing. So if I have two negatives, or if I have two positives, right? I'm still getting a positive 25 no matter what I do, okay? So the square root of 25, the number multiplied to itself to get 25 could be negative 5 or 5, right? We know that. But what if I add a third number? So what if I do negative 5 times negative 5 times negative 5? Well, that gives me negative 125. And if I do 5 times 5 times 5, it's positive 125. So I can do a cube root of negative 125 because I have 3 of the same negatives that get me that negative 125. So we are allowed to do the cube root of a negative number or an odd root. So 3, 5, 7. We can do that with negatives. We cannot do it with even roots with negative numbers and still get a real answer. So we get those complex, remember from the beginning of the year, those complex numbers? But we are not going to deal with those right now. Okay, we're only worried about getting real roots. All right. Here we go. You use a radical sign to indicate a root. You know this. The number under the radical sign is called a radicand, and the index gives the degree of that root. So what are the real square roots of 0.01, negative 1, and 36 over 21? Okay, well, let's think about it. So a real square root. So that means the square root of 0.01. It wants to know the square root of negative 1. And it wants to know the square root of 36 over 121. Oh my gosh, I said it. I didn't write it. There we go. All right. Well, what times itself is going to be 0.01? If you have a calculator, you can use it. Okay. The square root is going to be attached to this button, right? So second square root, right? And I'm going to do 0.01, and it gives me 0.1. Okay. It's the same thing. If you want to put this in a fraction, if you really wanted to, that's the same thing as the square root of, what, 10 over 100? No, 1 over 100. Here we go. I can do this. Okay. The square root of 1 is 1. The square root of 100 is 10, so it's positive and negative 1 over 10, which is the same thing as the decimal that I just got, which is positive and negative 0.1. Okay, so the square root of 0.01 is equal, I'm going to change the color of this, going to be equal to positive and negative 0.1. Okay, square roots, you always get a positive and negative answer. All right, what's the real square root of negative 1? There isn't one, right? That's where my I comes in. So this can't happen. Okay? There is no real square root of negative 1. A real square root of 36 over 21, well, just like my first example, do the square root of each piece. The square root of 36 is positive and negative 6. The square root of 121 is positive and negative 11. All right, so those are what our real square roots are. All right, how about cube roots? Okay, so remember, cube roots, we are allowed to do negative numbers. So if it's asking me to do a cube root of a negative number, that's okay, we can do that. Okay, so let's see what we have here. What are the real cube roots of 0.008, of negative 1,000, and 1 over 27? All right, so we want the cube root this time. Oh, I gave you the answers. Cube root of 0.008, the cube root of negative 1,000, and the cube root of 1 over 27. All right, that is also an option on our graphing calculators. Okay, you push your math button right here, push math, and you'll see that your option for a cube root is number 4. You want to push your arrow down to where we get the cube root. Okay, we push enter. There is our cube root. 0.008, which gives me 0.2. All right. So that's going to equal 0.2. There is no positive and negative. It has to be positive because positive times positive times positive is a positive. If any of those were negative, it would have flipped over to a negative, right? So this is going to stay positive 0.2, which is the same thing as the fraction 1 over 5. The cube root of negative 1,000, okay, is going to be equal to negative 10, and that's okay. Again, negative numbers. So I'm going to go in here. I'm going to go into my math. I'm going to do the cube root of negative 1,000. And see, it tells me negative 10, right? If I try to do the square root of negative 1,000, look, it tells me error, okay? You can't do the square root of a positive number. I mean, you can't do the square root of a negative number, okay? You can only do the square root of a positive number. All right, last one, the cube root of 1 over 27. Well, the cube root of 1 is 1, and the cube root of 27 is 3. So that's going to be 1/3. So notice my cube roots only have one answer, and technically my square roots have two answers. You have a positive and a negative of each. All right. All right, so let's find the real roots. So if I have x squared equals 100, well, how am I going to find x? Well, if I have a power of 2, the opposite of that is going to be the root of 2. So you have to take the square root of both sides. That's what's going to cancel out your x. If you square root a square, they're inverses of each other. So x is left, and the square root of 100 is positive and negative 10. All right. My next example, 5x squared equals 125. With this one, we can't square root right away. We have to divide both sides by 5 first. Okay. So now I'm going to get x squared is equal to 25. Now that I have a variable to the power of 2, now to undo that square, we square root, and we're going to get positive and negative 5. All right, number 21. Again, I cannot do the square root until the variable is by itself with that exponent. So I'm going to have to get rid of this 9 by dividing both sides by 9. So now we're left with x squared is equal to 16 over 9. I'm allowed to square root now. The square root of 16 is 4. The square root of 16 is 9. So x is going to be positive and negative 4 over 3. So we do the square root of each piece. Square root of 16 and the square root of 9. So we got positive and negative 4 over 3. Okay. Number 22, we got some stuff to move, because remember, I can't do anything until this piece right here is by itself. Okay, so I have an 18 in my way. I also have a 4 in my way. So the first thing I'm going to have to do is subtract the 18. All right, that's going to give me 4x squared is equal to 1. Now we will divide both sides by 4. I have x squared equals 1/4, right? I can finally undo my x squared by square rooting both sides. Square root of 1 is 1. Square root of 4, right? Square root of 1 over square root of 4. So that gives me positive negative 1 over positive and negative 2. All right, 23. Again, I need x squared to be by itself, so I have to divide both sides by 4 first. This gives me x squared is equal to negative 1/4. Now we square root both sides. I have a problem, don't I? I can't do the square root of negative 1/4. So because it's asked, we end up trying to do a square root of a negative number, this one does not have a solution. There are no real roots. The only roots this one has are going to be imaginary. Okay, they are not real. 24, we have x cubed equals negative 64. So if a square root undoes a square, then a cube root is what's going to undo a cube. So we're going to have to cube root both sides. I have a negative, but that's okay because the root I'm taking is an odd number. Okay, so the cube root of negative 64 is going to give me x equals negative 4. So a cube root of a negative number is a negative number. The cube root of a positive number is a positive number. All right, we got a couple more. 25, we have x to the power of 5 equals 243. So again, if a square root undid a square, if a cube root undid the cube, what's going to take away a power of 5? A root of 5. Okay, so we're going to fifth root both sides. Okay, so we're looking for the same number multiplied to itself 5 times, and it's equal to 243. Right? Again, graphing calculator. If you push the math button, option number 5, see how there's an x in front of the root? That's where you get to pick what the root is. Okay, so I'm going to pick that one, and I'm going to pick the root of 5. So now I have fifth root of 243, and it is equal to 3. Okay. If you have a scientific calculator, it should still have that option. Some of you might have to hit the 5 and then do the x roots and then do 243. So some calculators, you have to tell it what the root is first, just depending on what you have. If you're not sure what your calculator does, reach out to me and we'll figure out how to work yours. Okay? But the fifth root of 243 is going to equal 3. All right, last and not least, x to the power of 4 is equal to negative 16. So again, to undo the power of 4, I need the root of 4. So I'm going to fourth root both sides. Oh, that's a negative number, and 4 is even. So I can't do an even root of a negative number. So therefore, 26 does not have any real roots. It has imaginary roots. It does not have real roots. All right. I got 4 more. Okay. The final 4 are going to be dealing with variables and exponents and finding the roots of those. There is like a fun little trick I'm going to show you with these. Okay. So when we take the root of an exponent, what you do is you just divide your exponents. Okay, so here 27, we have the cube root of x to the power of 3 and y to the power of 12. That's the same thing every time as putting power of 3 over root of 3 and power of 12 over root of 3. So notice my powers, my rational exponents is what this is, okay? My power is 3, my root is, I'm losing it, kids. My powers are my exponents. That's the 3 and the 12. The root, which is in the ground, which is underneath it, okay? That's going to be 3. So we divide them both. So we're going to get a simplified answer of x to the power of 1 and y to the power of 4. Okay? So it looks complicated, but you're really just dividing. All right, 28. We have the fifth root of x to the 10th and y to the 15th. So I'm going to take x to the 10th and y to the 15th, and we're going to divide both of those by the root of 5. So this will simplify to x to a power of 2 and y to a power of 3. All right, I want you to pause, and I want you to try 29. So pause the video. All right, for 29, you should have gotten x squared, y to the power of 1, and then z to the power of 3. Because 12 divided by 6 is 2, 6 divided by 6 is 1, and then 18 divided by 6 is 3. All right, 30. What am I dividing by? I don't see your root there. Well, how do we read this? We read this as a square root. So when your index or your root is a 2, we don't always write it, right? It's very common, even in our calculators, there's not a little 2 written next to that square root symbol, okay? So if there's no index there at all, it's going to be 2, okay? So now 24 divided by 2 is what? 12. 8 divided by 2 is 4. 16 divided by 2 is 8. So your answer here is x to the power of 12, y to the power of 4, and z to the power of 8. All right? So we have lots of review that kind of happened today. Review of property of exponents and simplifying radicals. So your homework is page 363-64. I have a picture of these problems on your Canvas today. You are doing, I think this is like 21 problems, okay? So that is what you will do for homework, and if you have any questions, just let me know, and good luck. Bye.